Okay, so I want to work through the fifth problem on our review activity. And in this problem, we have a negatively charged droplet that has a diameter of 0.1 microns, and the droplet's made of oil, so its density is somewhat less than that of water. And the situation that we're looking at is that this oil droplet is suspended between two plates that have a separation of 5 millimeters. Problem then also tells us that voltage is the electric field times the distance over which that electric field is applied. And we'd like to know then the voltage that we need to keep this oil droplet suspended. So we've looked at a couple of cases in classes in which the particle was in equilibrium, in which the sum of forces equals 0. And so this is another such case. And in this case, then the downward pull of gravity is counterbalanced by the upward pull of the electric force. So we can expand the sum of forces as follows. The electric force is the electric field times the charge on the particle. And the gravitational force then is the density of the particle times its volume times gravitational acceleration. So we want to find this electric field E so that we can get the voltage by multiplying by the distance over which the E field is applied. So we can plug into this force balance. I'm going to convert my diameter to meters. And divide then by the fact that this particle is singly charged, and a single charge means a single electron, and an electron then has a charge of 1.6 times 10 to the minus 16 coulombs. This is the kind of fundamental constant that you'd be given on the midterm. Oops, we're off the camera a little bit. So if we plug in for this E field, then we get a value of 25.68 kilogram meter per second squared per coulomb. These crazy units are the same as volts per meter. And that makes sense then, right? Because if our voltage is the electric field multiplied by the distance over them, then this volts per meter times meter will give us a voltage in volts. So take our E field strength, multiply it by the fact that our plates are separated by 5 millimeters distance, and then we get a voltage, which is 0.128 volts, or 120